So this is the same circuit as the last video. I need to find the current I through this 6 ohms resistor and the voltage at this point using mesh analysis. In this case, the last one was done using nodal analysis. This one will be using mesh analysis. So I will assign two mesh currents. This one is, let's call it IA, and let's call this one IB. So now I will write KVL for each of the meshes. So this is mesh 1, and I will do the current is counterclockwise, so I will traverse in counterclockwise direction. So this 12 volts voltage source is a rise, so I will write on, let's say, left hand side. On the right hand side, this one, the current through this 4 ohms resistance is IA, so 4IA, plus through this one the current will be, since I am going counterclockwise direction, here it will be downwards, so the current will be, the resultant current will be IA minus IB, because IA is going downwards while IB is going upwards. So IA minus IB times 6, or it can be written as, if I write properly, just rearrange it maybe, so that will be 10 IA minus 6 IB, and this is 12 here. So this is equation 1. And then if I write KVL for the other mesh, this one with IB, the counterclockwise current, the voltage drop across 6 ohms is it will be 6 times IB minus IA in this case, and then the voltage drop across 2 ohms resistor will be 2 IB. And this one, this 10 volts voltage source, if it is gone when the current is, when we are traversing this way, this is a drop actually, so on the other hand side it will come as a negative sign. So this one can be written 10 and then minus 6A plus 8 IB. So this is equation 2. Now if I write this equation in matrix form, it can be written as like that. So IA and IB, IA and IB, sorry, and this one will be here, it will have 10 and minus 6, so 10 minus 6, 12, 10 minus 6 here, and then minus 6, 8, so minus 6 and 8, and this one is 12 and minus 10. So in terms of determinant form, in determinant form I can write IA as 10 minus 6 minus 6, 8, and here it will be 12 minus 10 and minus 6 and 8, like that. So this one becomes 96 minus 60 over 80 minus 36, which is 0.82 amps. This is the current IA, and the other current IB will be, the denominator will be the same, so I'm writing again though, minus 6 and 8, and then 10 minus 6, 12 minus 10, like that. So yeah, so this is becoming now minus 100 plus 72, and this is 80 minus 36 again, so this is minus 0.64 IB. So the current I through the 6 ohms resistance is downward, so I will be IA minus IB. IA is 0.82, IB is 0.64, negative 0.64, so they will be added actually, so 1.46 amps, and the voltage will be 1.46 times 6, which is 8.76 volts. So I have taken only 2 decimal points in this case, so that's why the result is 8.76 here, and the previous one was 8.73 in the, while I did it with nodal analysis, but otherwise it's the same. So if I just take 8.7, so It's the same problem. This one is using loop analysis, mesh analysis or loop analysis, and the previous one was nodal analysis. However, if the problem is given and we can see that there is there is not mentioned that how it has to be done, what method we have to use, we should actually use nodal analysis, because we can see that nodal analysis generated only one equation, while we used mesh analysis it gave us two equations. So nodal analysis is preferable. So it varies from problem to problem. When it is not mentioned what method we have to use, we have to carefully choose which method is most suitable and which method is the simplest one to use.